Hello, geometry students. Today we're going to go over the Unit 5 activity. So if you're on the Unit 5, go ahead and open up to that activity. And I'll go ahead and share my screen here. Okay, great. So the activity, if you're opened up to it, should look like this. We're going to go ahead and just kind of work on this. And go ahead and read this I'm going to read it out loud. Please follow along. It says the diagram below shows an equilateral triangle, triangle ABC. Okay, so what's key here is that triangle ABC is equilateral, meaning all of its sides are the same length, as well as all of its angles are congruent. They're all 60 degrees. And it's sharing a side with the square ACDE, ACDE. So each of these squares' sides, since it's a square, all of its sides are the same, and this equilateral triangle, all of its sides are the same. The square has a side length of 4. So not only is each side of the square 4, but also each side of this equilateral triangle is also a 4. See, since AC is 4 and it's equilateral, then that means AB is also 4 and BC is also 4. All right, now what is the length of BE? Justify your answer. So the first thing we need to look at is, what are we trying to find? We're trying to find the length of BE. So that's this length here, okay? BE. Now, what we want to do is I want to isolate this triangle here. So this is triangle BEA or ABE if you prefer. So I'm going to go ahead and just redraw it over here. And by the way, whatever I'm drawing, if you draw the same, it'll help you understand the material much better. Okay, so everything I do, you do. Everything I write, you write. So I'm going to isolate triangle ABE, and we can see it here. So this is the triangle right here. Okay. Now, a couple things to keep in mind is we know some of this information of this triangle. For example, the length of AB is 4, as well as the length of AE is also 4. Okay. Now, we want to find the length of BE. So one thing to keep in mind here is that, do we know this angle here? This angle BAE, this angle here? Well, we actually do know this angle. And the reason why has to do with the fact that this angle BAE is the sum of these two angles, this angle here and this angle here. The sum of those two angles adds up to this full angle, okay? So what is the measure of this angle here? BAC, this angle here. Well, I mentioned before that it's an equilateral triangle. That means each angle in here would have to be 60 degrees. So that's 60 degrees there. And in this square ACDE, well, each angle within a square is a right angle, 90 degrees. So we know that this is a 90-degree angle here. So what would be the measure of angle BAE would be the sum of those two angles. You see how angle BAE is composed of these two angles together. Okay, so the measure of this angle here is the sum of these, so that's 150 degrees. 150 degrees. Okay. Now with that information, we could use the law of cosines to help us find the length of BE. So for BE, I'm just going to call this length X. And this length is what's going to go on the left side of our law of cosines equation. Okay. So it'll be X squared equals, the two 4s are the two other side lengths. So 4 squared plus 4 squared minus 2. And again, whatever these lengths are, go into this part of the law of cosines. Ideally, you've done the rest of the packet up to this point, and you're hopefully familiar with the law of cosines and the law of sines before doing this activity. If not, then go ahead and watch my other video that goes over the whole workbook. All right, and then times cosine of 150 degrees. Okay, so here's where you're going to need your calculator, and we're going to need to do each of these parts. So it's going to be x squared equals 4 squared, so that's 16, right? 4 times 4 plus 4 squared, that's 16 again. Then we're going to do 2 times 4 times 4 times cosine 150. 2 times 4 times 4 times cosine 150. Okay, so this should give you plus 27.713. Okay, I would say make sure to plug this into the calculator and make sure you get the same thing. Okay, make sure you understand how this happened. And the reason it's a plus is because this negative here and then cosine of 150 is also negative. So it ends up being a double negative there, making it a plus. Okay, so now let's go ahead and add this right side of the equation. So it's going to be x squared equals 16 plus 16, that's 32, plus 27.713, 59.713. Okay. Lastly, to get x by itself, we're going to go and square root both sides of the equation to get rid of this squared. It's going to give us that x is 7.73. Okay. That's the length of BE. Okay. Now, it also says justify your answer. Okay, so I'm going to leave this part up to you, but I want you to explain in these lines here, I want you to explain not just that we use the law of cosines, but also how did we know all these lengths are 4? Okay, how did we know that this is a 60 degree and this is a 90 degree angle? Okay, so I briefly explained those things throughout the lesson. If you need to, you can rewind and listen to that again, but I want you to give an explanation there. That's how you get full credit. Okay. Now, once you're done with that, there's a second part to this assignment, and that's this part here. All right, I'm going to go ahead and read this one. A construction crew wants to hoist a heavy beam so that it is standing up straight. They tie a rope to the beam, secure the base, and pull the rope through a pulley to raise the end of the beam from the ground. When the beam makes an angle of 40 degrees with the ground, the top of the beam is 8 feet above the ground. Okay, so we're going to stop here for a moment, and we're going to talk about what they just gave us. So they said, okay, there's a person standing underneath this beam. I wouldn't recommend that, but this says the angle that the beam makes with the ground. So that's this angle here. The beam makes a 40 degree angle with the ground, right? So that means this is 40 degrees here. Okay. We could also see that there's this right triangle that's formed. So this is a right triangle, and the beam length is unknown. So I'm going to go and put X there. We want to know what the length of the beam is. Now they give us one other piece of information in this paragraph. It says they tie a rope to one beam, secure the base, pull the rope through a pulley, and raise one end of the beam to the ground. Okay. The top of the beam is 8 feet above the ground. So this, from the top of the beam to the ground, is 8 feet. So this length here is 8. Okay. Now we can use this information to help us find X. Okay. Now, since it's a right triangle, you don't have to use law of sines. If you remember, you could just use sine because you have opposite over hypotenuse. If you remember that from Unit 4. But if you don't remember exactly how to do that, no problem. We could just use law of sines. Okay. So what's key here is that we set it up sine of 40 degrees over 8. Remember, when using law of sines, use the angle and then the side that's opposite from it, right? These correspond with each other. This angle is opposite from this side, okay? And then what's our other ratio for this law of sines? Sine of 40 over 8, then sine of 90 over X. Sine 90 over x. Okay, great. From here, we could cross multiply. So that's going to be x times sine 40 equals 8 times sine 90. Okay, so I'm going to do 8 times sine of 90. And you should just get 8. And there's a reason for that. Sine of 90 is 1. So it's really just 8 times 1 there. So this just gives you 8. Then on this side, we have x times sine of 40. I'm going to go do sine of 40 in the calculator. Let's see what that is. Okay, so this is going to be x times 0.643. Okay, rounding to the third decimal place. X times 0.643. Divide both sides by 0.643. And this will tell us the length of the beam. Okay, so that gives us x, the length of the beam, equals 8 over 0.643. So in this case, the length of the beam is 12.44 feet. 12.44 feet. Okay. Now we're going to need this information as well a bit later. Okay. Now let's go ahead and read the second part of this question, and then it really comes into play what we're doing here. Okay. I'm going to erase some of this information here. So hopefully you didn't write in pen. Okay. You should never be writing in pen when you're doing math anyway. But anyway, the construction site has some telephone wires crossing it. Okay, we can see the telephone wires up here. Okay. The workers are concerned that the beam may hit the wires. So you can imagine if they raise the beam all the way, they're worried that's going to hit the wires up there. Okay. When the beam makes a 60-degree angle with the ground, the wires are 2 feet above the top of the beam. Will the beam clear the wires on its way to standing up straight? So we want to see, will the beam hit the wires or not? Okay. In this case, they're raising the beam. It was at a 40-degree angle, but now we're going to increase it more. It says that it's making a 60-degree angle with the ground. So now it's looking at a 60-degree angle with the ground. Okay. The length of the beam doesn't change, right? So that number is still handy. And then it says, when this is the case, this distance, the beam is 2 feet below the wires, right? Here it says the wires are 2 feet above the top of the beam, right? The wires are 2 feet above the top of the beam in this case. Okay, so now we know how tall the beam is. We know the total length of the beam. What I want to know is, well, how high are the wires? How high are the wires? So we know that this is 2 feet here, but if I could find this amount, then I could add this amount plus 2 feet. That'll tell me the height of the wires. Okay. Now I know what you're thinking. Hey, isn't that 8 feet? Didn't we do that earlier? Well, no, because earlier we were at a 40-degree angle. Then at that time, this was 8 feet, but now we're at a 60-degree angle. So when you increase that angle, that increases this height. Okay. So we don't know what this length is. I'm going to go ahead and call it y. All right. I don't want to use x because I already used x. I want to call it y. And we could set up another law of sines to help us find y. So in this case, sine of 40 over, or sorry, sine of 60 over y. So I'm going to put the work over here. Sine of 60 over y equals, and again, sine of 90 over 12.44. Okay. We're going to cross multiply, but remember, sine of 90 is just 1, right? So y times 1 is just y equals sine of 60 times 12.44. So 12.44 sine of 60. Okay, I hope you're writing this all down. 12.44 times sine of 60. That gives us that y is 10.77. Okay. 10.77. Okay, so how high are the wires? So the wires, therefore, are a height of 12.77. So the wires are 10.77 plus the extra 2 feet, right? So the wires are 12.77 feet above the ground, right? So I want you to write that out. Okay. In a complete sentence, the wires are at a height of 12.77 feet. Okay. Then will the beam hit the wires? What do you think? Okay, well, the wires are 12.77 feet. The beam is 12.44. So the beam will be able to stand up without hitting the wires, right? The beam is a little bit shorter than the wires. Okay, so I want you to briefly explain that since the beam is 12.44 feet, it's a little bit shorter than the wires, which are at 12.77 feet. So therefore, the beam will be able to stand up without hitting the wires. Okay, so briefly explain that. Okay, and that's the end of the activity. If you followed along and you put down what I asked you to put down and you put those few sentences in your own words and all that, then I'm sure you'll get a good grade on. All right, well, with that, take care and I'll see you next time. Thanks for watching.